Hi, everyone. We continue to discuss testing. So we do slightly different tests from the previous video. And also we discuss confidence interval for parameters estimated in logistic regression. Okay, so remember that we have the two models, L and S, in the theorem. And the null hypothesis is the smaller model, basically. So this is the model S. So that means the theta is equal to 0. So basically S is, in logistic case, eta is equal to beta naught plus beta 1x1 plus up to beta sxs. But the model L is larger. So eta is equal to beta naught plus beta 1x1 plus up to beta sxs. But actually plus beta s plus 1 x s plus 1 up to beta L xl. So we have L minus S more parameters. So in this case, we calculate the deviance for S and the deviance for L, then take difference. So dl is always smaller. Deviance is a kind of similar to the residual sum of squares. So this follows chi-square distribution with degrees of freedom L minus S. So we reject H naught if, okay, so this is slightly different. So ds minus dl is less than chi-square of L minus S of alpha. So example from R. Okay, so this time that so original model was LR. So predictors are cigarette and also height. So CHD, so the occurrence of heart disease is regressed on cigarette and height. So we have two more parameters. And we think about some intermediate model. So it's not a null model, but we only have cigarette here. So we have seen that the cigarette should be somewhat useful, but the height may not be useful information to predict the heart disease. So it's reasonable to compare the LRC, so only cigarette, and LR, so model with two predictors. Then actually the ANOVA function, even though this is a little different from ANOVA for linear regression. And actually this is analysis of deviance table, not analysis of variance. And analysis of deviance table that we give the ds and the dl. Okay, so this is the larger model. So okay, so L, model L, and this is model S. Okay, and deviance is, okay, so this is smaller model. So this is the deviance of S, and this is deviance of L. So difference is 1. Actually, just 1, maybe 1 point something or 0.9 something, but the deviance is 1. So actually 0.92, sorry, 0.92. Okay, so this is ds minus dl. So this statistic follows chi-square distribution with df1 because we have actually the 2 parameters in S and 3 parameters in L. So S is 2, L is 3. Okay, so including intercept, the S have 2 parameters and L has 3 parameters. So chi-square. So just compare this value with chi-square distribution with df1. So chi-square distribution with df1, that is just a squared normal, standard normal distribution, and the chi-square one, so probably like this. So 1 is around here. So the 0.920, this is actually even smaller than 0.1. So the p-value should be not very small. And actually this p-value is equal to this one, so 0.337. So we cannot reject null hypothesis. So L is not necessarily better than S. So with this result, usually we see this model, the model S, is sufficient to explain the heart disease. Okay, so so we finished testing, and just a small slide for confidence interval. So in linear regression, we studied that the coefficient, the estimated coefficient follows t distribution. So if we use t distribution, then we can calculate. And for logistic regression, that theory does not work. So basically, we have to rely on asymptotic property of the coefficient. So if we use the maximum likelihood estimator, then finally, if sample size is very large, then beta hat, so in general, the beta I hat, so this goes distribution. Okay, so yeah, so beta I, and it converges to the true parameter, and the variance. Variance that we don't discuss, but we can calculate the variance of beta I hat. You can see the as a textbook, such as the Introduction to Statistical Learning by Tibshilani and Hasti. You can calculate variance, and actually this goes to normal. So we rely on the normal distribution, and we rely on the Fisher information matrix to calculate the confidence interval. Okay, so we basically rely on normal distribution. Then we can see the confidence interval for intercept, and also the parameter of height, and the coefficient of height, and the coefficient for cigarette. And you can see, so these are confidence interval. So intercept is between negative 9.2 and 0.2 with probability 99%. Okay, so that means probably it's negative, but possibly it's positive, right? But for example, the cigarette has confidence interval ranges only for the positive side. So that means with 99% confidence, the parameter for cigarette is positive. Yeah, but the height, actually these numbers, so this interval includes 0. So we are not really sure if the coefficient of height is truly negative or positive.